8.6, day 1, solving exponential equations. And there's one basic rule here that we're going to talk about today, is we're going to start off with an equation that has an exponent. And so all of these apply, these rules apply. If this number right here is not 0, it has to be bigger than 0 and it can't be 1. So when this happens, if these base values are the same and the problem is equal, then that must mean the exponents are equal. And I'll try to make this make sense as we go. All right, so I'm just going to teach this through a series of examples. The first one is this: 2 to the x plus 1 equals 2 to the 10th power. So I'm trying to solve for x. I want to know what value for x would make these two things equal. Well, the goal for all of these problems is to try to make this base number the same. And this one's really good because it's already the same. So 2 to the x plus 1 equals 2 to the 10th. So since these are both 2, that must, and they're equal, it must mean that these two things are equal. So x plus 1 equals 10, so x equals 9. Let's do another one. 16 to the x power equals 4 to the 3rd power. So I want to try to solve for x. Well, the best way to do this is to look and see, is there a way I can make this number the same as this number? And there is, because 16 is the same thing as 4 to the 2nd power. So what I have here is 4 to the 2x power equals 4 to the 3rd power. So since I know that these are equal and they both have a base 4, that must mean that 2x equals 3, or x equals 3 halves. Example 3. 16 to the negative 3x equals 8 to the negative x. Well, on this one, there's no way to make these the same base, because 8 to the 1st power is 8, and 8 to the 2nd power is 64. 2 times 8 is 16, but 16 isn't 8 to any power. So if I want to try to make these to the same base, I'm going to have to break this down. 8 is the same thing as 2 to the 3rd power. And 16 is 2 to the 4th power. So what I have on the left side is 2 to the negative 12x, and on the right side I have 2 to the negative 3x. So now that the base numbers are the same, I can say that the exponents are the same. So I'm going to solve this by putting them on the same side. So I'm going to move the 12x to the other side. 0 equals 9x. So x equals 0 divided by 9, which is 0. Let's do another example of this. Remember, the goal is to get the base number the same. So let's do this one. 2 to the 2x equals 64. So I want to try to see if I can figure out what number would I put in for x that would make this equal. So since this is 2, it's a prime number, I'm going to see if I can make 64 2 to some power. So 2 to the 2x equals 2 to the 6th power, because 64 is 2 times 2 times 2 times 2 times 2 times 2. So now that this is the same, I can say 2x equals 6, so x equals 3. Let's do one more like this one. And then the next video we'll talk about what happens when the numbers aren't the same. So this is 1/3 to the negative 3x equals 9 to the 2x minus 2. So I want to try to get 1/3 and 9 to be the same thing. Fraction ones look scary, but really this is just the same thing as 3 to the negative 1 power. And this is the same thing as 3 to the 2nd power. So I have 3 to the 3x equals 3, and then I have to distribute to the 4x minus 4. So this means that 3x equals 4x minus 4. Subtract 4x from both sides. I get negative x equals negative 4, so positive x equals positive 4.